Okay.
You can make it full screen, maybe please go ahead. And give a pause, please, to record.
Okay. Okay. Thank you. Yes, I wanted to thank Latif and the other organizers. Especially, I presented an early version of this work at one of the at the last IEEE Morocco Blockchain Summit, and so it's a real privilege to be able to come back and present the update. So, as you can see from the title, the original motivation for this work was for privacy, to deal with privacy issues in distributed ledger technology. But more recently, we have been looking at applying it in other areas, in particular for Internet of Things applications and other areas where there is a need for editing or reusing blocks. So just a quick introduction for why is this important? Well, blockchain, of course, does have a lot of valuable properties, but it conflicts with some other needs. In particular, it conflicts with privacy and corrections or exception management. And this is because deletion is not possible. So what we can look at then is ways to get some of the same features but without blockchain. So we're talking about distributed ledger, but not a blockchain specifically. What we have is called a data block matrix. So what this gives you is the distributed trust and the integrity protection of a blockchain, but it allows for controlled edits for privacy regulation support or for reusing blocks. So here's the sort of the key points here. With the blockchain, you have integrity protection and write-only blocks. With this data block matrix, you have integrity protection and read or write blocks. And this is compatible with Hyperledger Fabric. We have a full implementation going, and later I'll present some details on performance of that implementation. So the idea here is that we can support some privacy regulations, but also applications where you have high volume and possibly low capacity, such as Internet of Things, because we can reuse blocks. That makes it possible to get by with less storage while retaining the integrity protection of a blockchain. So this is good for scalability. Any case where we have the ledger size as a significant factor. It was interesting this morning, Angelo Stavru presented some work that seems somewhat related to this for applying distributed ledger to Internet of Things, and this is maybe a different way of doing that. So distributed ledger technology, of course, originally looking at applying it to cryptocurrency, and blockchain fits very nicely there. That was one of the early motivations. It doesn't fit quite as well for distributed systems. Many distributed systems research papers you see will look at how to evade and get around the properties of blockchain. So what we're trying to do here is allow for additional distributed systems. And we can do this through the ability to change blocks or edit blocks, as we talked about earlier. So again, the permanence or the immutability conflict, the write-only quality of a blockchain tends to conflict with the right to erasure privacy regulations. You're probably familiar with the European Union General Data Protection Regulation, GDPR. Any user of a commercial service can require that all of their personal data be deleted. And that refers to any identified or identifiable natural person. And this includes pseudo-anonymized data. So this is significant. And there are some U.S. states, a number of U.S. states now are adopting these same rules, including two that are especially important for the internet, California and Virginia. So there is some other additional work that I pointed out. In addition to privacy, we're looking at applying this to Internet of Things, logistics, and shipping, anywhere where you need the capability for doing corrections, exception management, and also if you have limited storage, we can reuse blocks so that we can get by with less memory or data storage. So back to the privacy issues, there are a number of different other approaches for dealing with these privacy regulations that require data to be removed. One proposal, of course, is don't put personal data on a blockchain. However, financial transactions, which are typically a use for blockchain, these are clearly personal data. And another approach is to encrypt data and then destroy the key to delete that data in some sense. But that depends on the security of the cryptography. And of course, the original data encryption standard that was so widely used, it had to be replaced in only 17 years, whereas data about people must be retained for many, many decades, possibly forever. So that's a problem as well. There's also some various non-standard cryptography that has been applied, and also off-chain storage of the sensitive data. But then you have an index to that data, so that seems to be also sensitive. So we're looking at a different way of doing this. Again, many blockchain applications don't actually need blockchain, they need certain features. So what we do to make this work is we have two hash values per block instead of a linked chain. And this gives us distributed trust, integrity protection, and the immutability, or that you have mutability in blockchain. We have a block that can be edited or reused or modified as needed. This software that I'm talking about, it is going to be released as open source. It's incorporated into what we call next generation access control. And we're not trying to replace blockchain. There are many applications where blockchain is needed, where this approach that I'm talking about today would not necessarily work. However, there are other areas where this will give us greater flexibility. And so that's why this has been implemented using Hyperledger Fabric, and that component is available. This is the general approach here. Any applications that are currently using Hyperledger Fabric can be changed to use this data block matrix with relatively little effort. We can find all of the changes to Hyperledger code to a single sort module, the block storage module. So this is a quick walkthrough of how this works. Let's say we had a data block here in row 3, column 2, marked X there, and if we wanted to change that, then we have to look at the hashes. So we have hashes for each row and hashes for each column. So that block marked X has two different hashes. It has H3 for the row 3, and column 2 as well. So two different hashes here. And one more point, this is suggested for private or permissioned distributed ledger systems. It could conceivably be used in a public system, but that's not what we have implemented. We've done it in Hyperledger. So the way this works is if we wanted to delete this block here, row 3, column 2, let's say this is block 12, then that would change the hash value of row 3 and change the hash value of column 2. However, the other hash values are not affected. So as a result, there are two different hash values for every block. We have a row and column. So if we change that point at block 12, then we are still guaranteed that all the other blocks are protected. We can also extend this to 3 dimensions, In that case, we have 6 different sectors instead of diagonals above and below as 2 different sectors. But this is could be extended to more dimensions if we like through various programming structures. So why would we want to do this? Again, we want to use certain features of the blockchain. We want to solve the problem, the conflict between blockchain and privacy regulations, and reuse blocks. We can also reduce network communication. You can certainly do this, and this is done all the time with conventional database functions, but this adds the integrity protection that we talked about earlier. And since we can rewrite blocks, then we can apply this to cases where we have possibly high volume of data and storage is limited, such as Internet of Things applications. If we have a lot of transactions, images, whatever coming in, but it's a small device, then we don't have a lot of storage. So if we can reuse these data blocks, but retain the integrity protection, then we have some advantages. And again, it's designed as a lightweight, easy to use component for distributed systems. So this is this fairly complicated flowchart here is something that had been put together many years, quite a few years ago, to decide whether a blockchain is an appropriate technology. And as you can see, there are a lot of different hurdles that must be passed, different possibly barricades to using blockchain in an effective way. So the data block matrix that I'm talking about here effectively removes these barriers that are marked in yellow. So it makes it easier to use blockchain, or distributed ledger rather, so you can apply distributed ledger technology to more areas than you could a regular conventional blockchain. So again, it's designed to use the existing API as closely as possible. We can add blocks in the same manner as adding with a blockchain in Hyperledger. Also, this is configurable by channel. If you're familiar with Hyperledger, private subnets are referred to as channels, and you can set up your Hyperledger implementation or your application to use 2 different channels. One can be using the conventional blockchain, another could use this data block matrix. This is a website, and this is linked at the end also, where we have more information and some of the code. Quick summary of the performance properties. Latency for get asset, getting data, is relatively low. There is some increase for deleting assets, but in general, the average latency for deleting, as you can see here, is pretty good. So that's very useful property. And the throughput is also, on average, fairly good. And in most applications, this works very well. So we have a lot of data on the performance aspects, and the bottom line, the summary and important point is that we can use this version of the data block matrix implemented in Hyperledger Fabric for real-world practical day-to-day use. So effectively, anywhere that you're using Hyperledger Fabric now, you should be able to use this new form of distributed ledger technology also. This is links to more information on this work. We have the technical paper describing it, some introduction to why this is useful, and 2 different project websites here. One is the general approach and some of the information from different papers and presentations. And then we have the other one where we have more on the Hyperledger implementation. So that's all, and I hope that you find this useful. So thank you.
Thank you very much. You're perfectly in 5 minutes. That's also impressive. And if you can stay online, maybe for the Q&A session, which will come after 3 more speeches to go. So
yes, of course.